So my name is Scott Howard. I'm in the CTO office at Vast Data. And as the gentleman said, we're going to talk about storage in a HPC world. So for those of you that were at the vendor showcase a couple of days ago, you may have seen this slide. For those that weren't, as a real quick introduction to Vast Data. Vast is a company that's been around now for approximately 8 years. And basically we are a data platform company. So what do I mean by data platform? Basically a platform for storing all of your data, with one of our main focuses being the HPC and AI world. And I'll go into some more detail on that in a moment. From a customer perspective, we have a number of very large customers, especially in the HPC and AI space. Big names like the Texas Advanced Computer Center, as this gentleman here is wearing the Stampede 3 t-shirt with the Vast logo on the back. We are the storage behind that and behind some of the other systems at TAC, as well as many other large HPC systems like Sandia Labs, NASA Ames, and many others. So as I mentioned, we are a data platform company. What that means in a HPC world actually fits mainly up there in the very top left-hand corner, which is that we present out storage for HPC generally over NFS. Now some of you may cringe when I say NFS and HPC together. I've got a nodding head there already. We are actually a multi-protocol array. So we can also present data as SMB, as S3, and as well as some semi-structured and structured protocols such as SQL. We actually have an on-system database that we can present out as well. But I'm in Africa, I have to show an elephant slide, I believe, but let's talk about the elephant in the room, which is NFS and HPC. It is something that a lot of people will shake their head at and say that you cannot use NFS for HPC. And historically, that was probably correct. NFS was used in HPC environments going back many, many years ago, and it simply was not able to scale to the workloads or the requirements that HPC had. And that's where many of the storage products nowadays that are used in HPC came from. GPFS, Lustre, BGFS, all were really designed because there was a need there that products based around NFS could not provide. But along with those custom protocols come a number of disadvantages. A typical Lustre deployment, obviously the Lustre environment itself is quite complex, but really what makes this complex is these clients down here, and the fact that the clients really become a part of the storage cluster in terms of the software that they're running. And that leads to a lot of complexity in the environment that we can remove by using industry standard protocols like NFS. So a fairly simple diagram here of basic HPC setup, generally running some form of software on that HPC node to facilitate the storage. What about NFS? So traditionally, when people think of NFS, generally what they think of is the NFS that existed 5, 10, 30 years ago. I will admit I have been using NFS now for over 30 years. And until recently, it actually hadn't changed all that much. We had some improvements with networking and TCP, obviously, but the actual NFS protocol itself is largely unchanged since 1995 when NFS v3 came out from a performance perspective. And it really is limited to 2 gigabytes a second. And that's not actually an NFS limitation, that's a TCP limitation. Now the good news is that over the last few years we've seen some improvements. So Linux 5.3, going back about 5 years, introduced a thing called NConnect. Anyone familiar with NConnect? One person. So NConnect basically breaks the biggest disadvantage that NFS had, which is that single TCP connection. NConnect allows NFS to open multiple TCP connections and scale the bandwidth available basically linearly with those connections. So that means now we can push a single mount point on a single host pretty much up to line rate of a single Ethernet interface. Let's say 10 gigabytes a second, 100 gig networking, which is a pretty substantial jump over what traditional NFS allows. So this feature, as I said, it's just a standard everyday Linux feature. It's in pretty much any recent Linux distribution, Red Hat, CentOS, Rocky version 8 and above, Ubuntu 20 and 04 and higher, and pretty much everything else. And it is literally just add an option to a mount command. Presuming, of course, your storage supports it, which realistically most do nowadays. The other option that's actually quite common in Chpc is NFS over RDMA. If TCP is your bottleneck, why not just get rid of TCP entirely? And using RDMA allows you to do that. Now, a lot of environments don't like RDMA. They don't know, they don't understand it, they don't know what it is. Thankfully, the HPC world pretty much does. You know, a lot of HPC is based around InfiniBand, where this becomes quite easy. But even in Ethernet environments, RDMA can be used to break that single stream performance issues with TCP. So again, pushing up to line rate for a single interface. A couple of years ago, we started to see NFS multi-pathing come along. So VAST actually produced a driver for this, as has NetApp, and as have a few other vendors. And in fact, in 2021, a version of this actually went into the Linux kernel. So very recent versions of Linux, so RHEL and CentOS 9 and Ubuntu 23.04 have this built into it, where NFS can now not just open multiple connections to a single IP address, but open multiple connections to multiple IP addresses. Why does that matter? Well, with the previous mechanisms, we got to often line rate of a single interface over a single connection to a single file server. With multi-pathing, we can multiply that out over multiple interfaces on both ends of the connection. And in fact, we can take this a step further and use RDMA and multi-pathing together. And we can, I'll show you some real world sort of test results in a moment, but we can easily push over 100 gigabytes per second to a single host by using multi-pathing and RDMA together. Now, I don't know how big your HPC environments are, but I think you'll say, agree that 100 gigabytes per host is probably enough bandwidth for you. So some samples, these are just from our lab, showing the standard NFS that people generally think of when they hear NFS, that 2 gigabytes a second TCP limitation. NConnect, what's shown here is VAST NFS, basically multi-pathing using our VAST driver. And then what's shown here is GPU Direct, which is basically just NFS over RDMA, but specifically in an NVIDIA environment where the data is actually going directly to the GPUs. And you'll notice two things here. One is that the blue line, the bandwidth, obviously goes up for each of them. But the yellow line there is CPU utilization. NConnect and even multi-pathing do not really help us with CPU utilization. CPU goes up as the bandwidth goes up. But flicking over to RDMA significantly reduces the CPU utilization, and that's the nature of RDMA is that we're managing to avoid the CPU. So even though we may not need that to get the performance that we need from the network side or the file system side, it's often beneficial to use things like RDMA just for that CPU saving. Now, one of the problems when it comes to storage is there really is no sort of standard certification around, especially in a HPC style world, of what can a specific storage product do. The nearest that we have is actually our friends at NVIDIA. So NVIDIA do have certification based around their SuperPod environments. and basically they will dictate a minimum level of performance. But more than that, they will actually take products and test them against those standards. And in the superpod world, historically, there have not been any NFS-based products that have been certified as, superpod certified. And that's not surprising because, again, historically, until a few years ago, NFS just was not going to be able to provide that level of performance. But not surprisingly, when we went through the superpod certification recently, VAST was able not just to meet the requirements, but significantly blow them away. And obviously part of that is down to our storage product, but a lot of it is just down to the fact that we're using these new features of NFS, including RDMA and, in this case, RDMA, GPU Direct, and multi-parting. And you can see there, this is actually 290 gigabytes a second. And this was not from a particularly large VAST array. So on the VAST side, how do we do that? So again, those of you that were at the vendor showcase a couple of days ago will have seen this slide already. But basically what VAST is a very scalable, scale-out, unstructured data store. So we came up with a new design, a new architecture for how storage products work by basically splitting out the logic side of things and the actual storage. So the logic being where we do, for example, our NFS, where we do all of the data services that we do within the product. The storage basically just being our QLC flash. We are an all-flash product, and by breaking that model, we allow not just for scaling at both the performance and the capacity layer, but we also allow for very good parallelization. Because as this grows, you'll notice here, there's no line shown between these logic nodes. And that's deliberate. Our architecture is such that these nodes at the top here have no state. They're just pass-through nodes that allow your clients up here to connect through to the actual storage. The reason we can do that is because in between those two layers, we have an NVMe over fabric. So for those of you that aren't familiar with NVMe, this is basically a network running over the top of RDMA. And fundamentally, what it allows us to do here is have all of the systems up at our logic layer here having visibility to all of those SSDs at the storage layer, which just allows us for amazing performance and, especially in the HPC world, amazing parallelization. And because each of these nodes has access to all of these drives, we do away with that east-west traffic between the nodes, but we also do away with any locking and contention issues that are very common in a HPC world, which is another reason that we can do this on the front end using just standard protocols like NFS. Slightly more sort of detailed, not sure how well you can see that there on the projector, but slightly more detailed version of that previous diagram. And again, at this top level, we just have those stateless containers. They're actually running as containers. And as I said, the QLC flash down the bottom here, along with some storage class memory. What is storage class memory? For those that aren't aware, think of that as just being really fast, really high endurance flash. And we use that as a very thin layer across the QLC flash that we run, simply because QLC flash, it's good when it comes to economics, it's quite cheap, but it has some downsides. It's slow to write, it can often have very low endurance, but by putting some very fast, very high endurance flash in front of it, we can protect that QLC flash layer. And then when we mix that architecture with a product like NFS, we can get the equivalent of a parallel file system running across all of those systems. And again, that can scale as needed. I won't go into any details here, but if anyone's interested, at the end of the day, VAST is aimed at both the HPC world and the enterprise world. So that means we do have a number of enterprise features, which are things that traditionally haven't been available in a HPC world, but we are seeing people begin to use. So even things like snapshots. And if you've got scratch space running on a vast system, sure, we all know that scratch is not important, and if I lose it, okay. But being able to take a snapshot of that data and keep that even just for a short period of time can still be very, very beneficial in case someone accidentally deletes something that they did actually need. And a lot of these features, like I say, they're things that really have traditionally been more enterprise features, but we are seeing now used by a number of our HPC customers. So just a basic comparison between VAST and some of the both legacy NAS and HPC traditional file systems out there. Obviously, I'm from VAST. I'm going to tell you we're so much better. I'm not going to give us a cross for anything, of course. I'll finish up with a comment around multi-protocol. So VAST is designed from the ground up to be multi-protocol. What does that mean? It means that the same data that's stored on a VAST cluster can be accessed not just over NFS, as we've been talking about, but also over SMB and also over S3. And this is something that some people have done in HPC environments using gateways, but generally it's not something that works well. The way that we've implemented this, all of the data is available over all of those protocols, which can lead to some advantages it opens some options basically in terms of how you enable people to access your data. If you've got data that's being used by a HPC cluster that a user wants to access it from the Windows box, it's very easy to make that data available. And it's something we probably see more in the AI world. So we see a lot now, a lot of workflows like this, where each different step of a workflow can be using a different protocol. So in the life sciences world in particular, on the ingest side, a lot of the cameras and a lot of the microscopes historically have spoken SMB, because go back 20 years ago, they were based on, probably go back 2 years ago, they were based on Windows 3.1 systems. We're actually seeing that now shift a little bit more of doing things like S3. So we can ingest that data onto a VAST cluster over SMB or S3, but then we can process it over NFS. We can have our GPU training on it over NFS over RDMA to get that extreme performance. We can have our users interacting with it using SMB because that's the easiest thing to use for a Windows or a Mac laptop, and then potentially have that data distributed over S3. Or with a single copy of the data without having to use gateways or without having to move that data around between different systems. And obviously all with all the benefits that VAST gives from performance and otherwise below that. Thank you. I hope this was beneficial. If there's any questions. Thank you.
Okay, thank you. So yeah, my name is Zekman. Yeah, that's my English name. Of course, I do have one Chinese name. So my Chinese name is Ndau. So it's a little difficult for our friends here to know the Chinese name. So that's why I have the English name. And then the English name is from a very interesting thing, okay? So before that, before I'm in South Africa, I was in Latin America, like Mexico, like Venezuela. And then my local friends told me that, oh, so Zhang, you should have one local name. So that's the Spanish name. So they gave me the Ndau. And then 8 years ago, I came to Africa. 7 years ago, I came to South Africa. So I think I do need one English name. So at that moment, there are lots of movies like Spider-Man, like Batman. So in this case, I choose half from my Spanish name and then change Ndau into Zekman. So Zekman is my English name. Okay. So right now I'm in Huawei Enterprise Business Department in South Africa. Just like we discussed this morning, right now the relationships between China and the US are not so good, but it doesn't matter because, to be honest, from my understanding, no matter what are the product, solutions, and the services from West or East, we have the same role or we have the same target is that by using different product solutions and the services, even the technologies, to fix problems our customers are facing and reach their target and also bring the benefits and the values to our customers like CSIR, Chpc or other customers. At the same time, promote the economic and even the industry development in South Africa. So in this case, we just show our capabilities and also let our customers know what are the technologies we are using, and then they can choose which one is the preferred technologies or product and solutions to their environment. So that's why I want to use this topic and share our ideas and thinking about the high performance computing industry. Okay. So first of all, let's have a basic understanding about the high performance computing platform, especially the architecture. So it's very simple or very, familiar with everybody. In the bottom, of course, is the data center facility, including buildings, power, and then air conditions. Okay, this is a very important portion because if we don't have this, we can do nothing for the high performance computing. The second is about the infrastructure, including computing, storage, network, because this is the capability if we want to reach our target, including a lot of different kinds of computing types, no matter CPU, GPU, NPU, even DPU. So of course, right now, NVIDIA is the top one for the GPU, and then Intel, even AMD are very excellent for the CPU. But to be honest, for the research, for some industry scenarios, so CPU, GPU are not enough. Sometimes they need the network process unit to accelerate the communication between computing nodes or between computing nodes or between the computing nodes and the storage nodes. So in this case, we also need the network process unit. At the same time, all the researches or the projects will process data. So in this case, how can we accelerate the data process? We also need the DPU, that's the data process unit. So this is the storage, or this is the computing storage pool, okay? Except that we also need the storage because all the data are stored in the storage. And then based on different scenarios, we will have like a file system, no matter NFS or CIFS, or we have the object storage. Maybe we are using the S3, this kind of protocol. At the same time, we can use the Hadoop file system to process the big data related tasks. And then, so in this case, we also need a very huge storage pool. Okay. After that, we can use a lot of networking protocols. The very popular and the famous one, of course, is the IP. After that, we will have the locking, just like what the colleague has mentioned, even the NAS over locking, because locking normally is using in the SAN storage, but we can develop it and then use it in the NAS scenario. At the same time, we have the very high bandwidth IB or web channel, this kind of networking. But this is not the important thing I want to discuss. The important thing is that, you see, in the past 20, even 30 years, even 100 years, the high performance computing industry is going forward. But the steps are not so quick to catch up the technologies changing. this is one very important opinion, because the technologies are changing so fast. So you see, we know the artificial intelligence is very hot topic right now. I do believe in March this year, OpenAI launched their Chpc 4, okay, for the new generation. But right now, the Chpc is going to like generation 4.5, even Chpc 5. And then yesterday, Google launched their new generation artificial intelligence technology. That's very big challenge to OpenAI, even the Chpc. The report shows that Google artificial intelligence technology beats OpenAI 30 out of 32. So in this case, the technologies are changing so fast. And then we have to use the new technologies to promote or to do the transformation for our traditional high-performance computing. But another very important idea is that, or opinion is that, we cannot do the very motivation changing maybe in 30 days, 6 months, or even 1 year. Because, just like I mentioned, for this 20 or 30, even 100 years infrastructure is not so easy to change. So in this case, we can understand the new technologies. But how can we use the new technologies in our high-performance computing platform? We should consider it very carefully. So today, what I want to share are several new things from Huawei. And then customers, no matter from CSIR, Chpc, or Divisa, you can consider, so this technology is okay or not. Maybe you can do the comparison between Huawei and the other OEM vendors, and finally, you didn't choose Huawei, no problem, doesn't matter, because you choose the best one for your current environment, okay? So the first thing is about the new storage module for high performance computing. We name it as Ocean Disk, okay? So for Huawei Ocean Disk, that's the dedicated storage for master system. Because I know that in the high performance computing industry worldwide, more than 60% customers are using master as their performance management system, and also the parallel distributed file system. So in this case, we should also provide the new generation storage to meet customers' demands, especially the very mainstream software. And then so the benefits we have four, of course: performance, intelligent, efficiency, reliable. They are very common for each OEM vendor. So what we want to know is that, or want to share is that, for Huawei, we can also provide a very excellent and a professional service. That's also very important. Okay, so this is for Ocean Disk. So I don't want to introduce more about these new technologies, just that you guys have a basic understanding. And then if you are interested in these kind of technologies, you are welcome to visit our website, the official website, or come to Huawei office. We can do more introduction and discussion about it. So this is one thing. So what are the difference compared with the traditional J-board system? You just check the red characters. There are a lot of new functionalities to support the high-performance computing scenario in the in the storage side. Okay, so this is one very important thing. Except that we have two kinds of modules. One is the HDD based, another one is the SSD based. So HDD based is more like the capacity oriented. So it means that customers can choose this capacity oriented storage to store the very huge data for the high performance computing. Take the maximum specification as example. So we can use the 20 terabytes disks. Of course, all the storage vendors can use this kind of disks. Okay, there are no matter from Seagate or from West Data, doesn't matter. And after that, we can use very huge capacity. For example, if one system for the low capacity, we can support like 72 petabytes. Yes, that's the one system. And at the same time, the performance also not so bad. I can only say that's not so bad because the technologies are changing so fast. Maybe right now it's okay, but maybe 6 months later it's not so good. After that, I want to introduce the SSD scenario. So we can see here, if we are using all SSD, so for this kind of module, we can reach like 480 gig for one system. And then this is for the read, and also write, it's like this. And the same, if we are using Ocean Disk 1600 this module, we can reach this kind of performance. So this is only for one storage. And then the capacity is more like 750 terabytes. So it's very small sizing. But if the sizing is 10 times, so it's like 7.5 petabytes. It's very easy for high performance computing center to have this kind of data. So you can see that the performance can be very huge, like 4 terabytes, 2 terabytes, 6 terabytes. So in this case, this is also very good for our customers to choose if you have the performance scenario. Okay, so this is for Huawei Ocean Disk dedicated for master system. So after that, here's one case from China. There's also one computing center. So they are using Huawei in storage for SSD and also archiving. That's another story I don't want to discuss today. They can reach like 1,000 gigabytes for read bandwidth and also 600 gig for the write bandwidth. So it means that it's totally mature solution for our customers to choose. So this is for one reference cases. So another one very important topic is about the best practice in AI. So why I choose the best practice AI? Because AI is the next generation technologies or industry or Europe we should catch up. And in South Africa, we also should pay more attention on this artificial intelligence because that's one very important point for South Africa to catch up the steps in the worldwide. And then another thing we have to consider is that, just like I mentioned, it's not very easier for our customers to change their environment 100% new. Or it's not very easier for our customers to do the very motivation things to their current environment. So in this case, for the public cloud, no matter about public cloud or Microsoft or Amazon, doesn't matter. This is also one very important option for our clients to choose. For example, if it's very small and temporary project, and then we don't have enough investmental budget, but we have to finish these tasks. Why not just rent the cloud services? So that's why I'm saying different technologies can meet your different scenarios. Even like a student or research center, you can just pay very few money, but finish your task in 1 month or 2 months. It's not necessary for everyone to have their own assets, okay? But of course, it's very glad to see that Chpc has already launched their private cloud solution. So in this case, you can, all the students or end users can rent your Chpc cloud to finish their projects and also reach their target, okay? So this is also very important thing I want to share. And then, so what's the best practice from Huawei? And first of all, so in South Africa, we do have Huawei public cloud regions. Right now, we have three regions, AZs in Johannesburg. And then we're also going to have the AZs in Cape Town. So in this case, there will be several AZs in South Africa, and even some other region in Africa region like Nigeria, Kenya. So in this case, the coverage should be fine, and also the connectivity should be fine. So this is one simple introduction. So in this case, based on Huawei public cloud, so what are the best practice? Today I want to show you guys one, and it's a very small video, okay?
Huawei Cloud Penghu Model T's academic paper was accepted for publication in the top international journal Nature. This marks an important milestone on our journey of pursuing R&D breakthrough. Inaccuracy of AI weather forecasting has always been a challenge. Penghu Weather is the first AI prediction model to demonstrate higher precision than traditional numerical weather forecast methods. The model allows a 10,000 time improvement in prediction speed, reducing global weather prediction time to just seconds. The paper shows that the core technological breakthrough of Penghu Weather is by proposing 3D Earth-specific transformer to handle complex and uneven 3D meteorological data. The paper also uses a hierarchical time domain aggregation strategy to reduce the number of forecast iterations and errors. Nature reviewers commented that Penghu Weather has brought a new perspective into the future of weather forecasting models. Currently, top weather systems in Europe and China are already discovering the strengths of Penghu's predictions in real-world testing. 80 typhoons are generated in average each year, causing billions of dollars of economic loss and over 20,000 life losses. In June 2023, Penghu Weather was commented by ECMWF as a legitimate rival of the IFS, which is used as the benchmark for high-quality forecasting. In the future, Huawei Cloud will continue to invest in R&D to bring better services and reshape the industries with the power of AI.
Okay, so it means that right now we have the benchmark and the best practice in the artificial intelligence by using Huawei public cloud. But this is only one option, just like I mentioned. So how about the next one? Next one is that, so for South Africa, we have a lot of industries here. And we'll have a lot of students here in South Africa and research centers. So what in my mind is that, like CSIR, Chpc, or even some other organizations should build up your own artificial intelligence center. So why? Because different countries will have different situation, no matter the population, no matter the economic, even the culture. So in this case, if we only use the technologies or the data from outside of this country, and then when you ask the one question to ChatGPT 4 or 5, they will give the answers which are from outside, not the correct answers for South African citizens. Who can imagine that? So in this case, it's better for South Africa to build up the artificial intelligence center. It's national level. So why? Because all the organizations or research centers or students, they should easily to access this artificial intelligence center and then to start their research or build up their module. And then all the data is in country to make sure that all the intelligence can be located in South Africa. Okay, so this is one thing. Another thing is that because the artificial intelligence center is very expensive, I can take the ChatGPT as example. So for ChatGPT 3, the investment for it is like $3 to $4 million for ChatGPT 3 to build up the whole system. But right now, if we only to do one training for ChatGPT 4, you can imagine how much is it. So the statement from the former OpenAI CEO, he said that for ChatGPT 4, if I want to finish one time training, I have to spend $100 million. So it means that artificial intelligence is the money-eating machine. So in this case, it's not very easy for everybody to build up the National Artificial Intelligence Center. So in this case, for the whole South Africa, we should find a way to build up the Artificial Intelligence Center by using different vendors' technologies to meet different customers and industries' demands. For example, if NVIDIA GPU is very excellent, yes, of course, you can choose it. And then if their CPU is excellent or their Intel computing nodes is excellent, you can choose it. Of course, just like what the colleagues mentioned, if the vast data storage is excellent, why not choose? So in this case, all the options, all the decisions should be made by our South African customers and build their own artificial intelligence center to make sure that this is the correct way for South Africa to catch up the technology steps in worldwide. At the same time, you should have your own data in country and make the artificial intelligence to serve South African citizens, organizations, industries. Yeah. Otherwise, it's not so good for South Africa long-term development. Okay, so this is another thing I want to share. And the last one is about the security. Unfortunately, I didn't see a lot about the security for high-performance computing in today's session, because the security is also very important for the whole HPC industry. You are doing the research, you are doing the forecast for the whole country. If we cannot keep the data safe, and then maybe we spend like 10 million US dollars and 10 years, research result was gone. So what's the loss to these countries? So that's why I also want to mention the security for HPC data center. But of course, Huawei is only one vendor can do security, the data center security. And then you can, based on your data center scenario and also your business scenario, to decide what kind of security solutions you should choose. So the sharing from Huawei is that right now for Huawei, we can provide the network and storage collaboration, ransomware protection, this kind of solution. No matter from the edge to the internet or in the data center internal. And even from the storage side, the production storage side, to the backup storage side, and even for the very key data, you should have the isolated gap. So in this case, for this kind of solution, it's also very important to protect our research data in the HPC data center. That's why I want to mention the security for all the HPC industry. And then at the same time, I wish all the OEM vendors, even our technologies and production and solutions vendors, should also consider the security capability in your product and solutions. Because right now, the ransomware detection and even some other security issues are very dangerous to each country. Yes, maybe you will say that, oh, all the detections are from China. But do you know why? Because there are a lot of computing nodes are located in China. But some users didn't make their security protection well. So somebody, I don't know, maybe from US, hacked these computing nodes and then used this as a jumbo box to attack all the countries. So in this case, the lesson we should learn, build up a very excellent security system and also the data protection system to make sure that your very important data and your very important research result should be safe in this country and also safe for the whole South African citizens. Yeah, because if you spend so long time, so much money, and finally the result is gone, and then somebody use it. So how much the losses we will have for South Africa and citizens. Okay. So this is also one thing I wish everybody can remember in our minds. So finally, yes, this is the final slide. I want to say that for this very, how to say that? I cannot say that it's a very worse word and it's very excellent word. But right now, everybody is going to face the situation. Which situation? The world is changing so fast. At the same time, the technologies are changing also so fast. So we have to catch up our mind and steps to the new changing in the world and the technologies. So I don't mind the customers didn't choose Huawei solution and technologies. I wish customers can choose the correct one and then get the benefits and also do the contribution to South Africa, to Africa, and to everybody. Thank you.
Do you have any questions? All right, so I'll ask one.
Yeah.
What's the relationship, this is almost off slides here, but what's the relationship between Ocean Store and Ocean Disk?
Yeah, that's a very good question. So you see, in the beginning I mentioned for the very traditional data center infrastructure, it's not so easy for us to change it a lot or 100% change. So we have to pick up some very important or high priority things to do the changing. Why I discussed the Ocean Disk? Because right now, no matter HPC or Chpc or other customers, 60% are using master system. So why not provide a new module to meet the master system's demands? Otherwise, we have to change the whole master system. It's not a very easy and simple task. So this is one thing, okay. Another thing is that right now the artificial intelligence is a very, very hot topic. We have different ways to go. For example, by using the services, it's very simple. Just pay for it and run the projects or the tasks and get the result. And then, should we ask ourselves one question? Is this the result, the fact result you want, or this is the result somebody modified it to you? So that's why I'm saying that, yeah, some public tasks like the weather forecast, we can use the public cloud services. But if it's a very sensitive topic or very important research, why not build up the National Artificial Intelligence Center? Because this is under control. And this is the wish of the whole countries, no matter South Africa or China. So that's why I have the Artificial Intelligence Center. And another thing is that no matter the Chpc or the Artificial Intelligence Center, one very important thing is about the security. Because all these platforms are doing the research. If somebody modified the data, maybe the result is totally wrong. Or somebody stole the data, and then this country, the report was lost. And then we cannot transfer the research results to benefit our country, our citizens. So I just pick up several very important things, or from my understanding, and then share in this place. So in this case, everybody can understand that, oh, yes, I think we should pick up the high priority things to do, not just change everything, motivation, yeah. Okay.
Okay, just one comment. You may want to do an IO 500 submission with Lustre plus Ocean Disk and then Ocean Store plus Ocean Disk, because I think it might be a great sales tool for you, because I know how incredibly good Ocean Store is. So I have a lot of, I'm one of the founders of IO 500, so I know a lot about what's been going on there, and it's always been an incredibly impressive set of results there. So that's why I was curious why you didn't bring that up as an example, because I know it's a really nice system. So.
Yeah.
All right. So, all right, let's thank our speaker.